Alrighty, hey Math Leaguers, here is your session 2, week 3, midweek, mid-ish because it's already Thursday, sorry. Usually I put these out on Wednesday, but your midweek-ish hints. And I'm gonna start off with question number 9. And I'm gonna take you almost to the end. You know, if you're willing to sit through this video, you deserve a big hint, because this is a really hard problem. It gives this triangle, and this isn't here, and this isn't here, but it says that this is a 30-degree angle. It says this is a right triangle. It asks you, it says that this bisects this line bisects this angle, and it says the length of this line is 9. Gives a lot of information. Here's what you need to know. It's one of those things, if you're on a math team, if you do math counts, if you do things like that, your Pythagorean theorem problems, your right triangles, you need to know your special triples, like the 3, 4, 5, the 5, 12, 13, all of those. But you also need to know, when you get into some trigonometry, a couple of special right triangles. One of them is the 45, 45, 90 triangle. And on that one, you just need to know, and you'll learn why, but it's common sense, that the two legs are exactly the same because they're across from the exact same angles. So if this is 5 and this is 5, and it just so happens, if you work out your Pythagorean theorem, the hypotenuse is 5 times the square root of 2, 5 radical 2, okay? So literally, if somebody said, you have a right triangle and it's got a 45-degree angle and one of the legs is 7, then you know the other leg is 7 and the third leg, or the hypotenuse, is 7 times the square root of 2, okay? The other special one, that it's just something to memorize, is and I know this is pretty advanced, especially if you guys are like coming in the 6th grade, is the 30, 60, 90 triangle. And it just so happens in that one that the shorter leg, let's just give it a value for now, let's pretend it's 4, okay? The hypotenuse, the long slanty one, across from the right angle, is going to be double the shorter leg. And it just so happens, every time, the longer leg is the square root of 3 times the shorter leg. So again, if you know you have a 30, 60, 90 triangle, and they say that the short leg has a measure of 5 inches, well, then you know the hypotenuse is 10, and you know the longer leg is 5 times the square root of 3. Okay, so back to this problem. We actually have 2 right triangles within each other, but in the big right triangle, it says that the longer leg is 9. Well, so 9, and I just assigned a letter to the shorter leg. Since we already have A's and B's, I just picked randomly like W. So 9 is the shorter leg, we call it W, times the square root of 3. And then I could divide both sides by the square root of 3, so I actually have a value for W. 9 divided by the square root of 3. Okay? What it's asking for is this length, CD. This is a hard problem, so if you're hanging in there. It also says this line bisects this angle, right? So that means if it bisects, this was a 60-degree angle, so this is a 30-degree angle, and this is a 60-degree angle. Now you have a smaller, see if I have a different color here. Don't worry, I won't spend as much time on the other problems. This is the hardest one. You have a smaller triangle, okay, that is also a 30, 60, 90. But in this case, W is the longer leg. Okay, so the longer leg, W is, which is here, is the square root of 3 times the shorter leg. And I just called the shorter leg CD. Okay, so this is my equation right here. And then what I'm trying to do is get this CD by itself. So I multiply both sides by the square root of 3, and I'm going to stop there and leave you there. I've almost taken you to the end of the problem. Okay, hopefully some of you will get it. It's a really hard one. Number 8 was a really hard one. Also, I apologize. You know, sometimes I find these problems in books. Try not to break any copyright rules or anything like that. So I'll hand draw them myself. All right, and it gave a rectangle that was divided into 3 congruent rectangles. My picture, they didn't really look very congruent. And even my picture here on the board, all right, I could probably spend some more time working at it, making it look better. But anyway, it says that the area of this entire big rectangle is 1,536. Whatever it was, inches, centimeters, whatever. It says the 3 rectangles were congruent. So I just divide by 3. Each rectangle is a third of that, so 512, the area of each rectangle. Okay? Then I'm just going to assign some letters. All right? I'm just going to say that this, like we'll call it the height of these 2 rectangles, is x. And this, we'll call the width of the rectangle, we'll call it y. All right, and then for this like small rectangle, we could say that x times y is 512. If we look at this one over here, we notice that the y is the longer one, right? The x is the, so if you look across, y is equal to 2x. Okay, so you now have 2 equations that are true. I'm going to stop you there, but I'm going to kind of give you one more small hint, which is that this value, okay, I'm not going to say anything. All right, number 17, I think these are hard. It was like what fraction is a fourth of the way between 2 other fractions? I'm going to do the exact same problem, but just with different numbers. So here we go. I said, what number is a third of the way between 2 9ths and 8 15ths? Well, what do? Get a common denominator. In this case, 90. Okay, and 20 90ths and 48 90ths. The distance between them is 28 90ths. Okay. Now I want a third of that, so I literally just do a third times 28 90ths, and I get 28 over 270, which reduces down to 14 over 135. Okay, that's how far it is to go a third of the way, but it's actually asking what value. So I start at my low value, my 2 9ths, oops, that's terrible, my 2 9ths, and I add another 14 1/35ths to it, and that will get me a third of the way between the 2 things. Okay, so again, you're just getting a common denominator and adding 2 fractions. Okay, that was number 17. Number 15, I don't want to take you too far, but there is a pattern here, and there's some special things. It's really cool. I can't wait to show you guys on Sunday when we do the wrap up. But it's asking, if I draw 5 lines, what's the maximum number of intersections? Let's see. Let me make sure I got that. Yes, what is the maximum number of intersecting points that could occur? Well, if I draw 2 lines, I can only have them intersect in one place. 2 lines can only intersect in one place. If I draw 3 lines, what I want to do, I don't want to do that. I don't want to do a parallel line, because then I only have 2 intersections. What I want is for my new line. There's already 2 there, so I want my new line to hit both of them. The new one hits both of them. Now look how many intersecting points there are. 3. Okay? When I draw my 4th line, I want my 4th line, if I want as many intersecting points as I can, to touch all 3. And you're going to count up. You find a pattern pretty easily. I probably should have gone further than 5. Okay? And those are my hints. I know number 20 is really weird. It's a special problem. Just do your best. Looking forward to revealing that one to you as well. And then your challenge, your challenge for the week, your extra challenge is, I'm going to try to draw this really fast. Giving you a picture to draw on Desmos. And basically, I'm asking you to draw like Mickey Mouse. Okay? The head and the 2 ears. I'm going to tell you that there's a special formula for a circle. You go on Desmos. If you don't know how to use Desmos, it's okay. First of all, you don't have to do the challenge. Second of all, play around, try it, see what you can figure out. But anyway, the formula for a circle is r squared equals x minus h squared plus y minus k squared. Boy, that's fancy, right? Sorry to you guys like that are going in the 6th grade. But r is for the radius. H and k is the center of the circle. So if I want a radius of 1, 2, 3, 4, 1, 2, 3, 4, right? I'm going to write 16. If I want my center in the middle, okay, then it would be x minus 0 squared plus y minus 0 squared. Now you don't really need the zeros because x minus 0 is just x. But that might help you figure out how to do the ears. Now, at the end, there's ways to cut off like the ears and stuff like that. It's okay. You can get extra points for doing that. But if you do the thing, you'll get your bonus points. Okay? But if you can cut them off, if you can put 2 eyes and a mouth, okay? And you can do that using these circle formulas, then by all means, we'll give you some extra points. It's actually really not that hard. You could even make these elliptical and put little filled in eyes in between, and it really starts to look like Mickey Mouse, okay? But don't worry about it, all right? You can do it at any level you want. You're basically making 3 circles, and I kind of already gave you one. All right, have a great rest of this week, and looking forward to 2 more weeks of this, and a couple other things. Ms. Tanya, who is our merchandise person, she's still working hard. She's got a t-shirt for the league. She's just putting some finishing touches on it. So if you won the raffle and you get a shopping spree and you want to wait and see what her t-shirt comes out like, hang on for a minute. And the rest of you, if you just want to buy a t-shirt from her, our good league t-shirt is going to be coming out very soon. Okay? We'll talk to you next week or at the end of this week.